Now we come to the chapter loops and others, and what we do is we look how the objects behave in a pattern. So we, for instance, have the pattern 7, 5, 3, 1. Since it is repeated all the time, we can write it after it. And now we want to know what the objects are doing, and therefore we just see that this one is coming right here, the 3 is coming from here to here, the 5 is coming from here to here, the 7 is doing a really high throw here, and it ends up to be the 1. So when I look at the orbits, I see that this 7 is going to be the 1. The 1 is going to be the 7. So it's always 7, 1, 7, 1, 7, 1. And I could write it in this way. I can say, okay, the 7 becomes a 1, and the 1 becomes a 7, and then it continues in an enclosed circle, and then also the 5 becomes a 3, and the 3 becomes a 5. Okay. And then we see that this object here goes to be the 3, and the 3 is going to be the 5, the next 5. And when we have another example, which one? 3, 1, 2, 3, 1, 2. Then I see, okay, I always start with the 1 because they are the easiest. My 1 is going to be a 2, and my 2 is going to be the 1. And 3 is going to be 3, because 1, 2, 3, 3 weeks later. So I conclude, when I just look at the objects, they behave like this. The 3 is going to be the 3, and always will be the 3, and the 1 is going to the 2, and the 2 is going back to the 1. Okay? This is something we call a loop, because it goes to the same throw again. And this is an orbit. It's something that it fixed, but it's changing a little bit. And we don't have to write it a few times in order to come to this picture. We can also start here, and we count the digits. So when we start with a 7, this is my first. This is 1, 2, 3, 4, 5, 6, 7. So my 7 will end up to be landing here at the 1 in this pattern, because this pattern is always being repeated. So I know, okay, the 7 goes to my 1. Then I have a look at my 5. 1 is the next beat, 2, 3, 4, 5. Okay, it goes here. Nice. It looks the same, that's good. Then we got 3, 1, 2, 3 will end up to be here. And my 1 will go just 1 beat, and that will be the 7, because the 7 is the next thing we do after the 1. This is another way of counting it. It makes sense because when we got a really high throw and a few lower throws, we don't want to write down the whole sequence of number. So we have this here, this lovely pattern 7, 5, 3, 1, and we enumerate the beats. And we know that those throws will get rethrown on those beats. For example, the first row will be rethrown at beat 7, because 7 plus 0 is 7. The next row will get to beat 6, because 5 plus 1 is 6. Since patterns are repeated after the period, we can subtract the highest multiple of the period in order to see which beat it only will be from 0 to p minus 1, to see on which beat the object is landing, or the object gets rethrown again. And to make it clear, I choose this beat here, and there we can subtract the highest period, the highest multiple of the period. And the period here is, of course, 4. And okay, we subtract 4 here and we end up with 3. 7 minus 4, 3. Yeah, that makes sense. Then we got 6 here, minus 4 is 2. Okay, what else do we got? We got the 5. Okay, this is more than 4, so we subtract 4. We end up with 1. And the last thing we got is 4. And this 4 we subtract 4, and we end up with the result 0. Okay? And this is interesting because our result does not contain a 4 anymore, because when we have a 4 we can subtract 4 and end up with 0. So when we do this we always end up with numbers that are lower than the period. The period here is 4, so I will have the numbers less than 4. 3, 2, 1, and of course 0. And this is telling me, okay, this first row, that was my first row, that will end up at 7, will get in the pattern to be 3. So this is B3, so this will come right here. Bam. And my second row, which is 5 plus 1, which is 6, so will end up to be on B6. But because it's done in repetition, I can subtract 4 and it will end up to be here. Just another way of thinking about it, because you can do it in repetition and therefore you can subtract 4 as often as you want, but you don't want to become negative. So 0 is the limit. And with this row, it's the same. We have 5 minus 4, which is 1, so it goes to be 1. And this one goes to be 0. And the only thing that you have to take into consideration is that you always start with a 0 here. Okay. So let's have another example. My next example will be B1. Okay. And now it makes sense to do that because B1 is my new pattern. And this is a letter. And we use letters in order to express higher numbers. For instance, if you got A, it tells us we want a 10. And B says we want 11. Because when we write it as a sequence of number, and so forth, we see it as 1 and 1, but not as 11. And 11 it's a much higher throw than a 1 and another 1. So we will use letters to do that. And now, if we have our simple method, we just write it again and again, and to see where it's landing, it will take time. So I do the same here, right? Numerate the beats, and I know, okay, B is 11 plus 0, still 11, and then I can subtract the period, which is 2 here. So from 11, I subtract 5 times 2 to end up in B1. Okay. I also could do minus 2, which is 9. Then I subtract here 2 because it's greater than 2. Then I have 7, and then I keep that on and on and on, and I will end up with it's 1, right? 3 minus 2 is 1. And then I stop because this is lower than 2. And then I know, okay, it goes to be 1. Perfect. So I can just draw this. And the 1 is of course going to the next beat. But it's also 1 plus 1 minus a multiple of 2, which is just 1, 2, will end up to be 0. So this will go to 0, to beat 0. Okay, and this is kind of nice. And what we do here, we subtract 2, and then we subtract 2, and again. We have a specific name for it in math. And in math we call that modulo. It's an operation which behaves exactly like we wanted. So in math